Hey, hi everybody. Um, so I might be live as well, but to be sure, I recorded this presentation. So as Andreas mentioned before, we've been working on a tool to benchmark the QGIS server performances. Obviously, it is a very complex thing. The cases that we've been tested are based on real projects and on real data that are used in Kanton Solothurn, but still testing every single aspect of a possible deployment is basically impossible. So what you see here are some, or what you're going to see here are some selected cases that are very relevant to the deployments in Kanton Solothurn. Nevertheless, these are relevant cases. They do test a lot of data, and they, I think, can be actually very representative of what the situation is with QGIS Server. So what I'm going to show you is first of all some of the, well, a small introduction on what the tool actually is that I built and what it does and how it can be used. It is an open source tool. We haven't made the repository public yet because it still contains some data that are sensitive. So Andreas needs to clean up a little bit the repository, and then we will switch it from a private repo to a public repo, so everybody can actually have a look at the code that is running. It is here's what I was looking for. It is the results are already available on GitHub. It's a GitHub page. I can show you the address immediately. So for the ones that are interested already, it's opengisch.github.io/so-qgs-bench-results. And there you get all the list of all the analysis that were done. So let's go one step back, and first let's see what was used as a base. We took the combined access logs and print logs of a whole day, a whole business day at Kanton Solothurn, and parsed the whole logs, resulting in about 150,000 requests for the access logs and almost 40,000 for the print logs. So out of these data, out of these request URLs, I generated a list of URLs that was to be used then in the subsequent test. So how the tool is built is that basically one can set up a configuration for a configuration file for a certain set of QGIS servers, and here it is possible to set up different things, like how many replicas do we want of QGIS, some specific settings for the servers. For example, if we want to use parallel rendering, how many tracks we want to use. Obviously here we say parallel rendering true and then max tracks 1, so we're actually turning it off. QGIS FCGI processes, this is something related to the QGIS2 server Docker image that we are using. And what happens is that the tool goes through this configuration and starts building up Dockers depending on what we request. The example here, we see we are comparing the major version of QGIS, and that is why we create a base configuration, which has nothing really important. It just sets which PG service files we want to use, and that we want to use 6 replicas, so 6 Docker running parallelly, and that we do not want to, we just want to use one thread because we are comparing QGIS 3 with QGIS 2 as well. Here we could have actually said parallel rendering false. Then after that, we go and set up a QGIS 218, and we use a template Docker Compose QGIS 2. I'm not going to get into the details on what those things are exactly. The templates are basically other Docker Composes that set up a specific type of server. I'm going to show you one quickly. For example, the QGIS 3 Jinx. And here we see that it's just a compose that goes and takes a certain Docker that I built and that I use a lot, and it sets up some parameter by reusing what has been set up in the test configuration. Yeah, so this is the basic way it works. It was built this way because it needs to be reproducible, it needs to be reusable, and that's the plan. So to try eventually to have this testing infrastructure to be merged with other testing infrastructure of QGIS that already exist, like the one that Paul Blutier and Alessandro have been working on, so that we are getting more and more automated tests on the server so that we can guarantee that the performance is there. Now, to the actual test that was run. The first test that I want to show you is actually the one that shows some very interesting things, namely that in a generic case where we are testing QGIS 218 against QGIS 316 with a project that has various levels. QGIS 3 and QGIS 2 perform in a very similar way. If and only if the file of the project file that we are trying to render is small. As soon as we use, and when I mean small, I mean something up to about 1.5 MB with maybe 50 layers. So your usual project. What happens at Kanton Solothurn is that they have some very large project. They have one very large project which has about 1,000 layers and is about 20 megabytes of size. And here QGIS 3 is much slower. But we've been investigating further, and we already saw many places where this could be improved. So we are very positive that we will be able actually to make QGIS 3 perform much better there as well, probably getting down to the levels of QGIS 218. The very important thing is that we've noticed a big improvement in the 3.x line, so 316 very much better than 3.10 and 3.14. So for sure, we'll see at the end or very soon. The one key message is if you're using QGIS Server 316 is definitely outperforming the earlier the other 3 versions. Now let's go to another check, another more detailed test. Here we're testing something without labeling, a very similar project but no labeling. And here we see that QGIS 2 outperforms QGIS 3 by about 15%. So we do have a bit a slower rendering in this case, but we also see that 3.10 is actually up to 46% slower. So really here we can see this big improvement into the 316 version. Then if we go on to rule-based rendering, we also see here a little bit slower performances with 316 compared to 218, but again, big improvement compared to 310. Next test I'd like to show were a project which is mainly raster based. And here we see that actually 316 has an edge of about 22% over 218. So you see, it is very difficult to say the 316 is lower than 218. In some cases it is, in some cases this is not. We do notice that there are a fair amount of cases where 316 is lower than 218, but there are also cases where actually 3.16 is faster than 218. So I for sure would not say that that 316 is much worse than 218. I would say that 316 in some cases is worse by about 20–25%, and in the case where you have a very large file like the Kanton Solothurn has, then for sure 316 still has a big an order of magnitude slower. But as I said, we have already been following up this project with another project where we are actually profiling what is happening. This project was only analyzing what was happening, and now we are actually getting into the code, and we already found some very interesting places where some work can be done, for example, in the legend tree, where multiple requests, like the case for the big file, would actually get hit very heavily in the 3.x code base. And we are very optimistic that this will be fixable, and that we can also go on and fix that use case. Then one last thing I would like to show is about parallel deployments. So assuming that you do have a charge of about that you are getting about 10 parallel requests at a time, having multiple single-threaded instances is working obviously better than having one single instance with multi-thread turned on. Obviously here the case is that the whole process of creating the response and delivering the response is slower than just the rendering itself. So if you can go a bit more parallel, if you do have parallel, I run another test where we are doing only sequential requests, and obviously their parallelizing things doesn't help at all. So it really depends on how your server gets hidden, and that's where you need to decide if you do need more parallelization or not. But in the regular case of a fairly used web map server, then it should be that you're getting some parallel requests. As a take-home message, I'd say to close up, use some parallel if you have parallel requests. Try to, if you're using Docker, not to use multiple fastCGI in a single container. Try to be as pure as you can in the container, so that if the fCGI dies, your container dies, and your orchestrator will take care of restarting that. Then use 3.16 because it is the fastest 3.x, or 2.18 if you're still back there. But I urge to be on a 3 version. If you can, use small projects. They do increase performance a lot. And if you do have a large project about 20 megabytes or more, then QGIS 3 is an order of magnitude slower. But again, as I said, I think we can fix that in the next upcoming releases. And then QGIS, there are some settings that you can set, and one that works really well is QGIS Server Trust Layer Metadata. If you set up your layer metadata correctly in the project, then it will give you a lot of improvements on your cache. So to close up, I think very important is that we are analyzing and doing profiling, and we already found a lot of low-hanging fruits that we can take on, and that the improvements in the 3.x series is incredible. In some areas, 2.80 is still better, but I think that that's not going to be the case for much longer. Have a good day. Bye-bye.